All right, this is just a quick example of how to find the domain of this guy. So remember, domain is just all the x values that the function occupies. And for most of our functions already that we know, for example, our linear functions, if I draw a line, our domain is everywhere, right? So it's not super useful to talk about domain. But here we know that these guys have some holes and asymptotes, so our domain is a little bit more interesting. So what I'm going to do is just figure out what x cannot be. And the way I'm going to do that is just by factoring the denominator. This example is familiar because I've used it before. So I'm going to pull out that 2 on the bottom. And then I'm just going to factor the bottom. And this is going to allow me to figure out what the zeros are. So I get x minus 4 times x plus 2. Because, right, 2 times negative 4 is negative 8. 2 plus negative 4 is negative 2. Top is going to stay the same. I don't care what the top is in this case. I just care what x cannot be. So the top doesn't matter at all. So notice I have discontinuities. I have a hole or an asymptote. I don't care which it is at x equals 4 for this factor. So that tells me that x cannot be 4. So I'm going to use my not equal to sign here. X cannot be a positive 4, and x cannot be a negative 2. Okay? So my domain is everything but that. And here's where that interval notation is pretty useful. So I'm going to say my domain, imagine a number line, right? So imagine this is my x-axis, is everything to the left of 4, or we'll go left to right, everything to the left of negative 2, right? And then everything between negative 2 and 4, and then everything else. So this is backwards. This is negative 2. This is 4. And my domain is everything else. So here is where I think that interval notation that you guys have seen before, but most of you don't like quite yet, is really useful. Because it's easier to write this down in interval notation than inequalities. So inequalities, we'd have to do 3 inequalities, including a compound inequality. Interval notation, we can just say from negative infinity to negative 2. I'm going from left to right. Right? And then from negative 2 to 4, and then from 4 to infinity is my domain. Okay? So this says x exists from everywhere from before negative 2, and then between negative 2 and 4, and then everywhere past 4. Here's what the graph of this guy looks like. So here's my discontinuity at negative 2 right here. And then remember, we're smarter than Desmos now. Desmos doesn't give us the holes, but we would have a hole in here as well. And then everywhere else the graph is defined. So my domain is as we wrote it here.